The blocking step is extremely important since it ensures that the membrane doesn't have any empty sites in which the primary antibody would bind instead of binding to the antigen of interest. If that were to happen and we were to have the antibody binding to the membrane, we would have a lot of background, which is something we definitely want to avoid. In the science section, Gretchen has already covered the pros and cons of several different blocking agents. In this lesson, we're going to focus on different factors to consider when choosing those blocking buffers. For example, what type of membrane are you using? What is the label that you have on the secondary antibody? And so on. The ideal blocking buffer would bind to all of the open sites on the membrane without blocking or disrupting the antigen on our target protein. That way, it would completely eliminate background without affecting the signal that we see at the end of our protocol when we image the membrane. In theory, any protein that has affinity for the membrane but no affinity for a target protein should be able to be a blocking agent. However, reality is not that simple. Let's think about it. Membranes have different properties. PVDF and nitrocellulose are not the same thing. Antibodies are biological materials that are created very differently and they target different things as well. On top of that, the secondary antibodies can have different labels on them. And we're all working with different types of samples. So it would not be realistic to expect that one blocking agent would work for all of the different Western blots that we have to run. Some blocking agents are known to be more stringent than others, meaning that they provide a more efficient coverage of the membrane, leading to less background. However, each antigen-antibody pair is unique, and they will perform better with different blocking agents. So you will have to empirically determine what will be the best blocking for your particular assay. There are a lot of options out there, from protein-based to protein-free based blockers, as well as homemade or commercially available blockers. And we're going to be talking more about those on our next lesson.